these two cancel out. Positive 16 and no, wait, hold on. Positive 16. 1 minus 5 is negative 4. Negative 4 squared is positive 16. They don't cancel out. X squared, take the x squared across, or they cancel, because x squared minus x squared is 0. Plus 4x, take the 8 across, it becomes plus 12x, is equal to 16 plus 16 is 32 minus 4, which is 28. That means that x is equal to 28 over 12, which is the same as 28 over 12 is the same as 14 over 6, which is 7 over 3. Leave it as 7 over 3. Now we've got enough information to calculate the distance cm. The distance cm will be given by the square root of x2 minus x1 squared, which is 7 over 3 minus 1 squared, plus y2 minus y1 squared. 7 over 3 minus 1 is the same as 7 over 3 minus 3 over 3 squared, plus 1 minus 3 is minus 2 squared, all in the square root. 7 minus 3 is 4. 4 over 3 squared is 16 over 9, plus negative 2 squared is 4, so that's going to be plus 4, or rather plus 36 over 9, common denominator. 36 over 9 is 4. That's going to equal 16 plus 36 is 42. I lie, 52. 52 over 9 in the square root. If you want to, you can simplify that. I'm not really bothered that you do, but you can. 4 goes into 52 13 times. Square root of 4 is equal to 2. 4 was 4 times 13, which gave us 52, over square root of 9 is 3. So it's 2 root 13 over 3, and that's the simplest third form of the distance cm. The third one I gave you to do has this diagram over here. Please don't try and read it off your TV screen. It is in the exercise book. With point P, which has the coordinates negative 2 and negative 1, Q, which is A and B, R, which is C and D, and theta. I also told you PQ is equal to 8 units and theta is equal to 30 degrees. Now, I want A and B, which are the coordinates of Q. Unfortunately, I'm going to have to do simultaneous equations because I'm going to get two variables. What is going to give me my simultaneous equations? First bit of information, PQ is equal to 8 units, and second bit of information, theta is 30 degrees. Let's start with that one over there because it is simpler. Remember, m is equal to 10 of theta. That means that the gradient of PQ, because PQ is a line that just continues on, PQ, the gradient of PQ is equal to 10 of theta, but theta is 30 degrees. Now if you work this out on a calculator, you're going to get 0.57 something something. But if you use your table of special angles from trigonometry, which you should be familiar with, 10 of 30 degrees is equal to 1 over root 3. That means that your gradient of PQ is equal to 1 over root 3. How do we get our gradient of PQ? Remember, it's y2 minus y1, which is going to be plus 1, over x2 minus x1, which is going to be a plus 2. But that has to equal 1 over root 3. That means that root 3 multiplied by b plus 1 has to equal 1 multiplied by a plus 2. And that's equation 1. I'm going to simplify it a little bit more. A is going to equal root 3 b plus 1 minus 2. And that is equation 1 that I'm going to be working with. Unfortunately, we need another equation. I'm going to get that using the distance formula. Now PQ, remember, is going to be given by square root of y2 minus y1, which is going to be b plus 1 squared, plus x2 minus x1, which is a plus 2 squared, and that has to equal 8 units. Because that has to equal 8 units, what I'm going to do is I'm just going to get rid of the square root sign. That means that b plus 1 squared plus a plus 2 squared is equal to 8 squared, which is 64. I just got rid of the square root sign. Now before I take this any further, this is equation 2. Substitute that into their simultaneous equations. That means that b plus 1 squared plus, instead of saying a, I'm going to say root 3 b plus 1 minus 2 in place of a plus 2 squared is equal to 64. That means that b squared plus 2b plus 1 plus minus 2 plus 2 cancel out. So that will be plus root 3 times b plus 1 all squared. Root 3 squared is equal to 3. B plus 1 squared is b squared plus 2b plus 1 is equal to 64. That means that we have b squared plus 2b plus 1 plus 3b squared plus 6b plus 1 minus 64 is equal to 0. B squared plus 3b squared is 4b squared plus 2b plus 6b is plus 8b plus 1 is plus 2 plus 2 minus 64 is minus 62 is equal to 0. Divide through by a common 2. That means that 2b squared plus 4b minus 31 is equal to 0. Two times 31 is 62. Are there factors of 62 that can give us 4? Doesn't look like it. So what I'm going to do here is I'm going to use the quadratic formula. I'm going to say that b is equal to minus b, or minus 4 plus minus square root of b squared minus 4ac. By now you should be quite familiar with using the quadratic formula, so I'm not going to spend too much time on it. Minus 4 plus minus square root of 4 squared minus 4ac is going to give me